So we're going to switch them over to the slotted one. So the gauge wire that we're using should be using the red lugs, but we didn't have a ring one that was the right size to fit over our under our screws on our power supply. So y'all know what I'm talking about? Okay. So what we did, go ahead and get back into our screws, right? And get your module. And then what we're doing is we're running longer power conductors so we can get these things back up to our PLC, so we can power up our modules. So what do we need to power up on our PLC? Where do we need to attach power at? Yeah, on the PLC itself. All the L's, right, and all the M's. Everybody okay? So the L's are for the what? Yeah, that's the positive, and the M's are for our minus, right? So the first thing we did was remove the power supply control panel. The power supply actually runs down the back of the trainer. So when you pull out these covers, you'll see there's a metal case in the back of the mount, and this is where the power supply is actually at. So this is just our connection to the power supply. It's also our on-off switch, and yeah, we'll go ahead and cut it off. We got plenty of time. We're gonna go to the red, the actual spade, the slotty ones. Let's see if we got. Make sure we get one that. Make sure I give them out the ones that fits. Yeah. There's more down here, so we got plenty. So we're gonna go to the red ones, the spade ones. These will be a lot better fit. Yeah, they're actually. I'd have to look them up. That's just what I'm calling them. I think that's what they're called. Now, to pull your power supply out far enough, you're going to have to take your input box, your input panel off, right? And then, of course, this allows you to pull your power control out far enough. And, of course, what we're getting to is we're getting to these guys right here, right? The red and the blue. Of course, our orange wire we're going to mount on the red, and then the blue wire we're going to mount on the blue, right?
Can I borrow these?
I'd like you to know them. Make sure I get them up there. So this is the actual information that comes with each one of the stations that's on the Festo line. So we have a distribution station, the station I've already done. We have testing, processing, and handling. Those are going to be, how many stations we're going to do? 3? I think we're going to have one group of 3, right? So we'll be doing the testing, processing, and handling probably the next class we'll let them move over. The first thing that we're going to do, of course, and then I'll show y'all, is we're going to use special accounts on the computer. So instead of using the METSTU account, we're going to use ILT 212 B, C, and D. And the password's going to be the second one. So when you get to your login screen, and we'll go ahead and do that now, on the computer that you're going to be using, first of all, we're going to do this according to which station you want to do. So who wants to do which group? Y'all can choose this, or we can pull for distribution, testing, processing. These are the three that we're going to do. Anybody got any preferences? Y'all ran them over that. So you want to do the one that your group ran? Okay, that sounds good. Okay. So what we're going to do is the username. So whichever computer you're going to be using, you can go ahead and log off. Now you need to use the same computer, because when it's we can actually use any computer that's got TIA the way we're going to do it. But I'll show you that. So what you need to do is go ahead and log your computer off. So if you're going to do the testing, then your username will be ILT212B. Processing would be ILT212C, and the handling will be ILT212D. And that's going to be your username. Everybody okay? Y'all doing that? So log off the student account. What's that? It don't make any difference to your username. Usernames are not case sensitive. What's case sensitive is your password. Huh? They go right down the line. So the first station is the distributing station, and I've already done that. Then the next station, whoever worked on that one, that would be the testing. The next station will be the processing. The testing station is where the lift's at. It goes up there and checks the height. That's why it's called the testing station. The processing station, of course, would be the carousel. Right? And then the handling station, this will be the station that nobody did. So that'll be whoever did the distribution will do the handling. Everybody okay? Because the distribution has already been converted over, right? You understand? So whoever did the testing is okay. Whoever did the processing is okay. Whoever did the distribution will do the handling, which will be the robot. Are we okay? The testing will be B. Processing will be C. And handling will be D. So ILT, whoever's on this one will be ILT212B. Whoever's this one will use the username ILT212C. Whoever's on this one will be the ILT212D, right? Everybody okay? So the next time we do it, so and the password is still uppercase W, ELCOEM $, and it should log you on. Everybody okay? Now, when you go to my computer, let me go over there and show y'all. It should have done it. Now, I didn't get an opportunity to check this, but it should have already mapped 2 drives if you look at my computer. So when you go to here, and then go to computer, under network drives, network locations, you should have 2 drives. You should have one named students, and then you should have one labeled AUT, whatever your number is. Y'all know what I'm saying? Everybody okay? Is it there? Okay, sorry. Yeah, this is the first time this account's been logged on. So what it's doing is
I only got 18 and 82.
really. Then we'll take care of that. My scripts are not running for some reason. I don't know. We'll let y'all. What's that?
Where's that?
It should have mapped it automatically under My Computer, but if it's not, so what you're going to do is you're going to come up here and everybody just click on your Start menu, and then right down here in the text box, what I want you to do is put // Oops, I got something stuck in there. Yeah, / 172.25.80.35. Everybody okay? I know that's little, y'all can't see it. Y'all know what the / is? It's the one that's opposite of fraction, right? / 172.25.80.35. Now this is an IP address, right? Called Dotted Quad. It's an IPv4 version because it's a private network. Everybody okay? Now when you do that, this should have popped up on the screen. Did it? Okay. So what you're going to do, everybody okay? Everybody there? Gilbert, you're there? Yeah, and what we're fixing to do is we're going to manually map these. So this is pretty interesting to show y'all how you can do that. So what we do, when I'm on the server, let me remote into the server and show y'all how to do this. So this is the actual server itself. And this is true for just about any network. So it says my server restarted for some reason. I don't know if they So what you can do on if you got a home network and you have multiple computers on there, and you want to share information like your printer and all that neat kind of stuff, it's really neat. Well, in your on your computer, what you will set up is you'll set up what we call a home group. So when you go to My Computer, you have work group. When you go to My Computer, you right click on My Computer, and then you go to Properties. And then when you do, in Windows 7, you'll have to go to Advanced Settings, and then you'd go to My Computer. And then what you would do is then you'd go down here and go to Change. And then what you would do is you'll specify whether you want your computer to log into the domain, or you want to set up a work group. A work group is a peer-to-peer network, which means what? What's the difference between a peer-to-peer and a domain? Any computer can share things and any computer can mount things. So every computer is considered a server and every computer is considered a client on the peer network. So this is probably what you would set up at home. So that way, if you got a printer on one computer, you don't have to do what? You don't have to take your other computer in there and set it down and unplug your printer and plug it back in. You can do it that way. A lot of your new computers actually are wireless. So you would go in and tell the printer that you want to share it on your work group. So work groups and domains are just a way to organize computers. What's nice about a domain is you set up a computer that is the controller of the domain. And what you do there is you set up user accounts on that domain, and you can set the rights and permissions for anybody without going into a computer. That makes sense? So what we would do, of course, to make it available on the network, what we would do is we would come in and, where's my desktop? Is we would just go to My Computer on any computer, and then you'd find the resource you want to, and then you would just right click on it and choose what? Sharing and security. And when you click on that, what it does is it gives you, you can give it to everybody, or you can just give certain users on their individual rights. You can say, okay, so-and-so can use my printer, but so-and-so can't, right? You understand? So any folder on your computer you can share, and that's what we're doing. So if you look at mine, I don't know if y'all can see it or not, but every one of these folders has a little hand under it, which means it's what? It's shared. So now it's shared. But what I had the ability to do is when I shared it, what I did is when I set up security, I shared it to only to that group, right? So if you try to access ILT 212A, it's going to come up and say you don't have permission to use that. Okay. So every computer has that right. So what you're going to do is when you're looking at this, is whatever your group is, what you're going to do is you're just going to highlight it, and then you're going to right click on it, and one of the options right down here at the bottom says Map Drive. Y'all see what I'm saying? Yes or no? Everybody okay? And you click on that, and then it'll pop up and show you the contents of that. Now, right now, that is going to be, well, no, I'm sorry. When you click on it, it's going to ask you, okay, what logical letter do you want to assign that drive? Okay. So what we'll do here is we'll assign it. It should come up Z. So everybody just assign that to Z. That's the default, right? Everybody okay? That makes sense. And it should have popped up, and a folder pops up, and it's going to be empty. Why? Because y'all haven't put anything in there. The next thing that we're going to share, this is where most of our manuals are, is everybody should have rights to students. So you should be able to right click on that and map that, and I think it's going to give you why. You can go ahead and choose why. Everybody okay? Huh? Students. Yeah, students is we give permission for everybody to use that, and that's where we put all these manuals at. So right now it's been wiped out because we lost our domain server, so I had to rebuild our domain server. Huh? Okay, then I hadn't given y'all permission yet. So what I did on a domain, what we can do on a domain is we can, am I still logged in on that? So we don't need it now, but what I can do on a domain is, what I did is when I set up your user account, so this is where I set up user accounts. Well, what I did is I entered the name, so this is your user account. And on the domain server, what you have the ability to do is to yeah, we can make you a member. We can make you a member of a group. And then instead of me coming in and assigning everybody permissions on everything, if I make you a member of the group, then I can give the whole group permissions. So what I'll do is I'll go back and add y'all all to a group, and then I'll go back and redo the permissions. That makes sense? So I think I had a group out there called PLC3. I thought I already did that. Now there it is. But what I'll have to do is I'll have to do it for each one of y'all, and I'll give y'all access to students, but everybody had access to the drive, right? Okay. So when you load up to your portal and you give your project a name, then when it gives you the path that you want to go to, you're not going to use the default path. What are you going to do? You're going to choose browse and then go to your drive. And then from then on, that's all you have to do. So now after that, anytime you create a program, anytime you save it, or anytime you load it, then that's where it's going to show you that. Everybody okay? So what we just did is we looked at a little bit about sharing, setting up a network. So what a network allows you to do, it allows you to share resources, right? Share and map resources, and it's really, really powerful. So I can print to I can print to my printer from my iPhone at my house, because I have it what? I have my printer's what? It's shared. And if it's shared, that means your printer, you can map that thing in different locations, which is pretty neat. Okay, so what we're fixing to do now, guys, is we have our printer set up. Everybody's got the 2 wires running out, right? Everybody okay? So let's talk a little bit about the wiring diagrams. And this is what y'all have access to. But, I don't know if I put them on Blackboard yet or not. I thought I did. Let's look real quick. So normally, so Blackboard, and this is where y'all can go and look at things. Oops, wrong password. So, well, I think a couple of people in this class did not do your first week's assignments. Some of y'all haven't done your syllabus agreement, so y'all need to go ahead and log in and do that right now. Whether you want to get points for that other stuff, you can't get credit for the assignment because it's way past due. We had 2 assignments that was due the first week. You were supposed to go out and do your syllabus quiz or read your syllabus, dress code, and all that kind of stuff. Then the second assignment was that you were supposed to send me an email. One thing we do that right off the bat is to make sure that my email sorts you into the right folder for this class. And every once in a while, for some reason, it likes to put people in junk mail. And I won't even show y'all my junk mail. It's really big. So that's why we require you to do the second assignment. But also what you were supposed to do, so you can't get credit for those assignments if you didn't do them. But you can get the points that are awarded for doing the syllabus quiz, for doing, and you've got to do the syllabus agreement, right? You understand? You have to agree with the syllabus before you can do what? Set in on this class. You can still get credit for doing the syllabus quiz, and you can still get credit for doing the safety and evacuation quiz. The other ones, you can't get you can't get credit for assignment 1. Okay. So what we do is it should be inside of course content, and then also.
Hey, look at this demonstration.
What's that?
The one I was telling you about. The question.
On the
Question I was doing 14. It's asked about how many rock.
Now, this class there's not going to be any. I think I went back and corrected it, but I gave y'all some credit. Another thing that was wrong, I don't know if it was this class or the other class, and I made the correction. I gave you credit for that, was Mr. Sanders' number. It's not, his number is 2082, 929-2082, and it was wrong on the brief, so I had to go back and correct that. This is the wrong class. It's down here. I'm just going to see if I've uploaded these documents so y'all can look at them. Of course, it might have been in the other class, so you got to do this for every class, right? Labs. No, so I hadn't put up all the documents yet, so I'll do that. And they were available on Student Drive, but like I said, we lost all that. So this is the diagram for the control module, which is, or the control panel, which is on front. Okay. And this is what I was talking to Anthony about. What we're using here is symbols that we use in the in here is a little different than what you learned in motor control. Motor controls are using what we call U.S. customary symbols. These are symbols that we use over here. All these are going to use ISO symbols, which are international standard symbols. So the symbol they use for any type of push button, any type of switch or manually operated contact is they use these symbols right here. Now, if you see the little dash line with the top on it, that means it's a push button or some type of push button. So this would be a normally open push button. This would be the international symbol for a normally closed push button. Y'all see the difference, right? Can y'all see that? All right, I need to blow it up a little. Okay. So this is the international symbol for a normally closed push button, which gets kind of confusing because it kind of looks like it's open until you see the little L shape. This is a symbol of a detent, which means once you put it in one position, it stays there until you do what? Put it in another. These are spring return. These are momentary contacts. So if it's not a momentary contact, then it's going to have this little indent on there, which means you push it, right? And then it latches, and then you have to push it again for it to do what? Unlatch. This is a momentary contact, which means what? You push it and you let it go. It's only made. This is a symbol for a key. So this switch has a detent in it, but it's actuated by a key. So if you go over there and look at the Festo box, there's a key on the front of it where we can switch it from auto to cycle, right? And then of course this is another push button. I can't remember. I know the S2 is the stop button. Why? Because it's normally closed. But I think this is the start. I meant to label this. This is the only place that they didn't label that. I think this is the start, which would be S1. This is the stop. This is the auto manual key. And then this would be the reset key. Push button, I'm sorry. And this right here, this goes to what? Input 1, input 2, input 3, input 4. And these are hooked up to sink or source. Guys, there's 24 volts, so these are hooked up to source. So that means my inputs are configured to do what? Sync. Everybody understand that concept, right? We talked about that a lot. This is the ISO symbol for indicator lamps. Oops, it was up there. Let's see if that defines it. No, it don't tell us. Here it still don't tell us that. And I need to figure out, we'll figure out as we go along because the Siemens PLCs, but I need to come back and label these two. So this is the ISO symbol for an indicator lamp. They're called a P1, P2, P3, P4. Which one is on the start button? So we have one on the start button, we have one on the reset button. We don't have one on the start button. And then we got two other ones that we use on the control panel. So two on the bottom. Everybody okay so far? And I need to come back and label this for you. So when you see in your PLC diagram, when they talk about this, P1, that's going to be this slide right here. And then it'll label it. It'll have like reset and stuff like that. And y'all be able to do that. Are we okay? Okay, so this is the other diagram. So we'll just look at one of them. I don't know, we might have to look at multiple ones because they have different symbols in there. So this will be on the student drive. Instead of me uploading it to YouTube, to Blackboard, which will take up a ton of space, what I'll probably do is just put them on the on that student drive and figure out how to show you how to map those. So here's the circuit diagrams. This is distribution. I've already done that. So let's go down to testing. And the circuit diagrams. And then we're not concerned with the pneumatic. What we're concerned with is the electric. PLC has nothing to do with pneumatics. It controls the valve, right? You understand? So this is the electrical diagram for this station here. And we know if it's inside a rectangle, it's a watt. Not a rectangle, inside a square, what does it do?
You put it in some more through.
Huh?
You put it in some more.
Not much. Yeah, I can, but it's going to be hard for me to find my way around it. Okay, so what's the square symbol for? We talked about that. Oh, was that in this class? That means it's some type of sensor. It's usually a proximity sensor. And this also, and this is the diamond shape. It's also, so there's two things that indicates it's the sensor. It's the square and the diamond shape. Then this indicates what type of sensor this is. So this means this is a capacitive sensor. Okay. And what does capacitive sensors do? We've already talked about that a little bit. What can they detect? Huh? Almost anything, right? And then it has one contact that's normally open, and it has a normally open contact that it controls. Now, whether it's solid state, we don't care. All we know is that whatever it senses, that contact would close between these two lines right here. That makes sense? Everybody okay? Now, this is a 3-wire sensor. A 3-wire sensor has to be powered up from an external source. So this would be plus 24. This would be 0 volts, which is minus, right? And then this right here would actually be the signal wire. Now this is a standard color code. A VN, what anybody know what VN would probably stand for? Brown. VU would stand for blue. VK would stand for black. So this is what you would have to do if you're wiring it up. Now we don't have to look at this much because these are already wired up for us on the terminal board. But if you went over there and found this guy right here, then you would see it would have a black, blue, and brown wire coming out of it, which gets us kind of confused because we like to use black for what? Ground, yeah, or common. This is a photoelectric sensor. This is a photoelectric sensor transmitter. This is a inductive sensor. An inductive sensor senses metals. Okay. This is an inductive sensor. This is an inductive sensor. This is a receiver. So this would be a through the beam, right? You understand? So a through the beam has a what? A transmitter and a receiver. Are we okay? Now, when I follow this down, the first thing you're going to see is the wiring on the terminal board. I'm going to have to reduce this down, guys. So this is our terminal board. So they come up here and this is 0 volts that comes down through here, right? Y'all understand that? And this is 24 volts, right? And then we come over here, and then this right here would be 0 volts. This says so this says it goes to input 0. Then this says it goes to pin 13 on our connector. You know what I'm talking about? Yes or no? The connector that you had to unplug that connector, right? You understand? And then you plugged in the simulation box up there. Well, that connector, that's the connector, and it would be pin 13. Okay, do y'all understand so far? We connect, what do you mean? Right, this is the connector that runs from the from the module down to the PLC. Okay, y'all understand that? So that means what I have to do is I have to take pin 13 and then I will hook it up. I'll translate that and hook that up to one of the inputs on my PLC. You understand? So what we got to do is figure out which pin 13 comes out of on the other side of the cable. Now this seems pretty complicated, but this would be how I would have to do it if I had to go from scratch. What Festo has done is that they basically, we'll show you the pin out, and it's really, really neat. It's a lot easier to do. The cables that we run to the PLC are really straightforward, and what they do all this wiring inside the module. So these are the two modules. So on the 1500s, this is wired up through a terminal board. On these, what we're going to do is we're going to run cables from the PLC up to the terminal board. Oops, did I close that? So this is where the cables that run up to our PLC, these are where they're going to connect. And then these wires that come out of the top, these are the wires that we're going to connect to the PLC. Okay, understand? So we got to translate it from not the terminal board on the back, not the terminal board on the actual, let me pull this out. In fact, we're gonna actually wire the PLC before we mount it, especially the outputs. The inputs we don't have any problem. The outputs, when we mount it on that end rail up there, there's not much room to look and see if you get it on there right. So we'll probably mount the outputs. So these are the cables. These are the cables right here that we're concerned with. How do they wire these to these right here, right? You understand what I'm saying? So this is what we're concerned with. And then, and that's really straightforward. They really did a good job. So these are the two connectors. So we have cables back here. Y'all probably saw them. These are the two connectors where we'll hook our cables up. And then these will come up and plug in. One of them will plug in, A will plug into the little terminal board that we plugged our simulator in. B is going to plug into the control panel. So one cable will be for the control panel. You know what I'm talking about, right? And the other cable will be for the water, or for the terminal board on top. And this is for analog. And unfortunately, there's only one module, and that's the tested module that has an analog signal on it. So Nancy was in here the other day, and they sent some bad parts, and they put it on there, and it was supposed to reject it, but it didn't, because we're not comparing a certain height to a certain color. All they're doing is if it's within the range, if our A to D converter just says if it's within this range, it's bad. If it's out of this range, it's good. If it's not in the range, it's bad. Originally what we have the ability to do is if I put a red one in there that's too short, it should do what? It should kick it out. But we don't have the ability to do that because we're not using that feature. We could use that feature if we use that analog, the analog. So yeah, ours don't look for color. Ours just looks to see if they're the right height, right? You understand what I'm saying? And we'll figure out which one here we're going to use. This is the E-stop. This is the weirdest E-stop I've ever seen. We're not going to use this as the E-stop anyway. Then we're not going to use all these, and we're not going to use all these. So what we're going to do is we'll take some of these out and we'll roll them up and tape them together, and I can store We can use this thing, and I've talked to Nancy about this, to buy this to use in PLCs. So use these in PLCs instead of the trainers we got. So what's nice about these guys is we can mount just about any PLC on them. So as we upgrade our PLCs, all we'd have to do is just snap one on there. Right now we have no option to upgrade our PLCs because the PLC trainers that we use, the PLCs are not replaceable. All right, does that make sense? So let's look at these symbols. So we probably need to know these symbols, right? And they're a little different than what y'all learned in motor controls. Okay, Rick, I have to. Just won't let me switch. Everybody okay on the symbols? So this is a symbol for a what? Capacitive sensor. This is but this is the transmitter, right? This is a through the beam transmitter. The arrows are pointing out. Does that make sense? So note here the arrows are what? Pointing out. If I go over and look at this other one, the arrows are pointing what? In. Right? Does that make sense? And I don't know if Festo uses right. This has a normally closed contact in it, right? Okay. These are what? Normally open. Everybody okay? This guy right here. So this is a through the beam. So it goes false when something comes through it, right? You understand? So that's why this is normally closed. Are we okay? That makes sense? Oh, dang it, Rick. And like I said, instead of uploading all these to the to Blackboard, what I'll do is just put them on there. And that's all the inputs on this section. These are all outputs right here. Let's look at those two. I'm sorry, because we're going to have to wire up outputs too. So we're using solenoid operated directional control valves. So what is a directional control? What do you think a directional control valve is? Controls the direction of flow. So it allows us to use it to extend these cylinders, right? You understand? And also it allows us to shift it and cause it to do what? To retract it. Does that make sense? So these are manually operated directional control valves. This is what we put together. This is what the Festo line is like. So this is the manually operated directional control valve. What you can see, it's got one inlet port and two outlet ports. You can't see the exhaust. The exhaust actually comes to it. This would be a two-position port. It's just one valve. The exhaust, we will have to put it right. Now, you're manually shifting those, right? You understand that? Well, if we can manually shift them, it looks like we should be able to electrically shift them. It's just like your car locks on your door. You can manually unlock and unlock them, or you can lock them or unlock them electrically, right? So we have a valve. So this is the symbol of the valve right here. The little hourglass. These are the solenoids that shift the valve over. So these are two-position double solenoid operated valves. So we activate one solenoid to switch it over and route air in one direction, right? You understand? And then we would actuate the other solenoid to shift it in the other direction. Everybody make sense? These valves right here, notice we've only got one solenoid. So we use a solenoid to shift it over, and then there's a spring inside these. So when we deactivate this, the spring automatically shifts the spool back over. So these would be solenoid operated spring return. This would be what we call a double solenoid operated valve. So we use solenoids to shift it in both directions, right? That makes sense? Yes or no?
Solenoid double operated.
Now this is a double solenoid operated valve. This is a solenoid operated spring return. That makes sense? So on this one, when I activate the solenoid, it's going to cause the actuator to move. When it turns it off, the spring returns and it automatically comes back. Are you okay? And these connect to the minus. You'll see these connect to the minus, right? So that means my PLC would be sourcing, right? Makes sense? So here's the actual PLC connection here. They're using O0, O1, O2, O3, O4. So that's not a 0, that's a letter O. Are we okay? So here the PLC is sourcing and the outputs are syncing. It's not going to say minus, they're using 0 for the minus. Y'all right down here. So notice it says 0 volts, 0 volts. And then all of the solenoids are hooked to 0, which is minus. Are we okay? Everybody okay? So I don't know of any other, let's see. So on our directional control valves, we got double solenoid activated, or we got solenoid activated spring return. That's the only two valves that we have, which is pretty standard. All the valves that we have are what we call two position valves. So we have valves are going to have they could have up to 3 positions, and that's all. So a 3-position valve would have a center position that we could set certain things up. We have what we call 2-position valves. So these guys only go in 2 positions, like the one I handled you. One way would shift the air one direction, the other way would shift it the other, right? Does that make sense? And then we have to exhaust it. And we exhaust through the valve, by the way. So let's see if there's any more symbols we need to look at. That was for the testing. I think the testing station's a little different because that was testing. There was one input that I didn't see. And I blew it up so much, that's probably why. Maybe I didn't go down. Yeah, so this is the A to D converter. I see it go down far. So these are the two outputs. So this is the symbol for a watt. That's a big yonder. That's the ISO symbol for it. And then this goes over. All we do is see these two right there. No, I'm sorry, this is the actual analog. The output is actually up the top. Okay. So we're not using the actual analog output. We're not bringing it down to the PLC. Okay. All we're doing is bringing this guy down right here. So this is the A to D converter, and we have the ability to set a limit. So we have the ability to set an upper limit and a lower limit, and that's all we can do here. If we were to use this analog signal, then not only could we, then we could tell if it's the right size for the right color, right? You understand? So then we can say if it's too short and it's red, then we could reject it. Or if it's too tall and it's black, then we could reject it. All we're doing is just looking at it over a certain range.
You said we're gonna access to these diagrams?
Yeah, you will. Right now you don't. Because we used to have them inside. So we had a student drive that we had available, and we lost the domain server crashed. It was doing a constant reset. A constant reset. and it wouldn't restore. There was no restore point. We couldn't do that, so we had to redo the whole domain server. When we redid the whole domain server, then we basically lost all the documents that we had up there. So we're going to have to reload them. Well, what's nice about the domain server is it's not eating up Blackboard space. The more junk we put on Blackboard, the longer it takes to copy. So originally, when I started recording videos, I would actually put the videos, I would import the videos into Blackboard. It took 3 days to copy one of my lectures, one of my Blackboard sites, because I had one. And I'm sure all the other people really enjoyed me because they only do one copy at a time. So they put you in a queue or put you in a line. This happened to us this time where computer science was copying over their online classes. So these online classes, everything has to be there, right? And it took 2 days for us to get our copy on our AUT 199 class. We had it ready, and I think that's basically all the symbols. There's no other sensors we have. We have photoelectric sensors. We have capacitive sensors. We have inductive sensors, and then we have the potentiometer on the height that we're not even using anyway. So what we're going to do is, and that's what I would have to do. I would have to figure out what sensors goes to what input and what goes to what outputs on my PLC. What's nice about this, Festo has made it a little easier in that they've done most of this for us. They've arranged these cables real neat. You can, when I first started this, of course, I was dealing with these cables right here. And then what I was doing is I was taking my ohm meter and going out here and putting my ohm meter on each one of these pins, figuring out which cable it went to. And then I took a piece of tape off and I would tape it on which input on the PLC was supposed to go to. And so if you look at mine, across the top, you're going to see a bunch of little tapes up there. And if you look at it, it's got I0, I01. Then I realized they're arranged perfect, so you don't have to do that. First of all, what do you think the red wire is? Now, this is power. So this is one of the things this is what we're going to use to send power. This comes from the power supply. So if I turn this thing on and I measure to this guy right here, it's going to be 24 volts right there. So that's already ran for us. So that means all we have to do is take these red wires now and hook them up to the different power requirements for our PLC, right? Y'all understand? And then they run power. Then the power also is already wired up here for us. Okay? So not only is these guys going to power up our PLC for us, it's also going to do what? It's also where we're going to hook up our inputs and hook up our outputs. And these are not the ones we're using, I think. I think these are the ones we're using right here. I think one of them's A and one of them's B, but we'll look at that. So I gave you the diagrams that comes with the book. So when we got our guys, it came with 4 books inside it. And of course, I only gave you one because these are different languages. So I gave y'all the English language that I ran off. So get that thing that I ran off for y'all. Wrong language. What did I do with that? Everybody okay? Y'all need to take a 10-minute break? I mean, a 5-minute break, I'm sorry. Okay, y'all take a break. About any trainer we want to on this thing. Okay. As long as it's got DIN compatible, but we got 2 of the different types of DIN rails. There's only one more, so there's pretty good chance that we'll be able to do this. And I don't think I'm going to be able to rotate this. That might. So these are all the different modules that you can get for this trainer. So we can have an analog module. We got all kind of different modules we can buy to put this on. The two that we have is we have the 16-bit input module, and we have a 16-bit output module. And if you look at the input module and output module, you'll notice they're labeled not in words, they're labeled in what? Bytes. So the input module is pretty easy to identify. It's the one that's got all the switches on it.
Is bottom input?
No, what do you mean? Yeah, that's where you would connect the inputs to. If you wanted to wire inputs, you would put the switch in the center, and you could actually hook true inputs to that thing like that. So that's a good question. The outputs, we can turn on LEDs like we did the other day, or you can hook up the outputs to those things. But the PLC uses a source and input, so you'd have to go from your positive output of your power supply to all your different inputs, right? If you was gonna wire them in yourself. Y'all understand what Melvin was asking about? I mean, does everybody understand? Yeah, this is the input module that Nancy got, and we can input using these switches. So they have momentary contacts, one direction, or we can leave them on or off all the time, right? Or we can put them in the center position, and we can wire real inputs to this guy right here. I could wire push buttons, I could wire sensors, I could wire anything I wanted to, digital sensors to these inputs right here. But notice all we have here, so since these are syncing inputs, what I would have to do is I would have to take a wire from the positive and run it to all my input devices, right? You understand? To set them up to source, because these inputs do what? Sync. This is the output module. It turns on these little lights every time we generate an output. If we wire this module up, then every time I generate an output, this little LED would pop on, similar to what we're doing over there. Or I could do what? I could connect real output devices out here, right? That runs off the power supply, so I could run a pretty good load off these devices right here. These are not running off the PLC. These are running off the power supply. Okay, does that make sense? So she bought this module, so we got 16 inputs, 16 outputs. So all we got to do is just mount any PLC we want on this thing and wire it up. That's what we're doing. We're going to hook up the inputs. We're not going to hook up the outputs. And why we're going to hook up the inputs is we can do things, but we're going to use one of these switches as what? Our E-stop button. So we'll hook up one of these over here. Now notice these run in groups of 8. So on our PLC, we have no problem. It's just that this might be input 0, 1, input 0, input 0.0, right? This would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Then we're going to have to go to input 1.0, right? You understand? Even though they just start over with 0 here, we'll go to 1.0. If we was hooking it up to an Allen Bradley PLC, then we'd go from 7, then we'd go 8, 9, 10, like that, right? So that's how I hooked up this guy over here. So that's the way this guy's, because that's an Allen Bradley PLC. So Allen Bradley PLC goes in words, Siemens PLCs goes in bytes. So every time you go from 0 to 7, then you got to go to another byte number, right? You understand that? Everybody okay there? So we'll go ahead and hook up the input. So up on our inputs, we're going to have two cables going to it. But we'll start up wiring this one up first, and we'll come back later and wire that up. It's just that right now, it will not work because E-stop won't be available. So what they've done on the 1500s is they've hardwired the So on the 1500s, the E-stop is true all the time. So there's no E-stop button. They just wired it to power to make it look like a normal code switch. So there's no E-stop on the Festo line over there now. Are we okay? Now, what we're looking at is this is the module that we're going to wire up. And when you pull it up, you notice it's got this big cable right here. This is the analog. We're not going to use this. So what we can do is we can go ahead and unplug this. And why we're going to do that is that if we don't do that, we're going to have to tape up all that power and ground, because if we leave it inside the PLC, then we're going to create short circuits. So it's best just for us to do what? Just take this connector out. Everybody okay? So y'all got y'all's, go ahead. This is the module. So here's A. So A module is going to wire up to the actual terminal board at the top, and then B input is going to wire up to the control panel in front. So if you go over there and look at mine, you see two cables coming. So we're just going to go ahead and pop this guy here out, and then we can just, what we're going to do is we'll get a piece of masking tape in a minute, we'll roll it up and tape it together, and then we'll store them somewhere. Not the two little ones, the widest one. This is the analog. Everybody okay? So this is the one you're pulling out. That leaves 4 conductors up here. We call these ribbon cables, by the way, for odd people. Some people call them flat cables, but I learned them as ribbon cable because they look like what? Ribbons. Are we okay? And we already know what the red wire is. What's the red wire? Oh. Now, what we're going to do is when we start looking through this manual, and guys, if I can figure out how to rotate it, I will. This is a PDF file. Is we're finding the wiring for this one module, and so we got to go through a lot of modules to get there, right? So what we're doing is we're looking for the wiring for this module right here. So we're going to start fanning through the book, and they got pictures of it, right? And we're looking for this module right here. Oh, no wonder I can't find it. It fell off. So we're looking for this module here. So let me turn. I'm gonna have to turn mine upside down so that. Okay. And so what we have here is we have the wiring. This module right here. Okay, everybody on that page. So what page is that? 43. Then I'm gonna turn the page. And then it gives us a bunch of information. And then on page 45, this is the wiring for the analog. We're not using the analog, right? First, I'm sorry. Let me zoom on this. Let me zoom in on this a little bit to show y'all. Okay, so this is our module. Now, when you look at it, so we know that this is the wiring. This is the way we're going to wire up the A module. This is the one where these are the two for the B module. Everybody okay? See what I'm talking about? So the A module, the A connector, I'm saying connector. So here's the A connector. This is the connector that's going to go, we're going to hook the cable up to this, and this is going to go up to the terminal board on the module itself. This is the one you disconnected when you connected up the simulator, right? You understand? The B port, this is the one that goes to the control panel, where all your push buttons and all those lights hook up to. Okay. So when we flip it over, these are the two cables right here. Okay, sorry. These are the ones that goes up, and if we pulled it out, it would go up here to these wires up here, right? You understand that? And then the other two, these two down here would be for the B module. Everybody okay? That makes sense? Okay. So when I look at my diagram, it says the outside one. So this one down here would be the A module, because it stacks on top. Then what we're looking for is 5B6, huh? Okay, so this is the one that stacks on top. So what's the outside one? The outside one is the A connector, right? And then this would be the B connector, and all this right in here is for the analog. So this would be the B connector. Oh, I'm sorry. This would be the B connector. I'm looking at this upside down. So this would be the A connector. This would be the wiring for the A connector. This would be the wiring for the B connector. Okay, does that make sense? Yes. You can write on this. That's why I gave them out to you. I would write in pencil, so that way if you need to erase something, if I make a mistake. Are we okay? So this is the A connector. This is the B connector. And then we have the two small cables. The cables have 1, 2, 3, 4, 5, 6, 7, 8. That looks like 10 wires coming up. Now you can see the way these are numbered. So it's got 1, 2 right here, what identifies, so they go back and forth. So they go odds down one side, even down the other, right? So all this would be 1, 3, 5, right? You understand that? Yes or no? Yeah, the pin numbering on the actual connector. So all the odds are down one side, all the evens down the other. But that's not really important, huh? It won't be really important for us anyway. The way we're going to wire it up, and it's really neat the way they came up with the scheme. It's going to be real easy to wire it up. Like I said, I was literally taking an ohm meter, going to the front here, and then trying to figure out what plug. I plugged this in, and then I was trying to figure out how to do this. And what's going to be easiest for her to do is before we mount the PLC to go ahead and wire it up, right? And then you don't have to worry about it. So that's what we're going to do. So we can unplug these cables. We'll probably need to put a piece of masking tape and make sure we label which one's 5 and which one's 6 and which is 1 and 2, and that way we'll plug them back in. So we can literally take these cables off these modules and just just wire the PLC out here, and then we can drop them back through the hole and all we got to do is just remember, make sure we plug them into the right slot. Okay, does this make sense so far? Okay, so what I'm going to do is I'm going to start turning the page. This is the connection for the analog. We're not going to use that. So this is the connection for all these different connectors on here. Now, which ones are we looking for? Let's go ahead and document that. So my A, we're going to be using SV5 and SV6. This is back over here. I'm sorry. I keep jumping. So what we need to do is when we look at this wiring, they give us the wiring for a connector. So what I'm going to do is I'm going to say, okay, A is going to be used what? SV5 and SV6. We're not using the big ones. We're just using the 10-pin cables, right? You understand? And then B, the B cat connectors are SV1 and SV2. Do y'all see where I'm at? Yes or no? So I'm back on page 43. Yeah, because we forgot to do that. So this is my fault. So let's look at page 43. And these are the connectors we're using right here. So this is B. These are the two we're using for A. Okay. So B is going to use SV1 and SV2. Y'all see that? Yes or no? Yes. Okay. A is going to use what? SV5 and SV6. Everybody okay there? Okay. Now let's go over to the wiring. So now I'm going over to page 46. 45? I'm on 46. Well, look through there. It might not have, look through there because I did fronts and backs and it might not have ran right. So these are ran directly. These are not front and backs. I ran these off. There's a 46 in there somewhere. Yeah. Page 46. That's the most important page. Well, how did that happen?
We don't have no ether on the page.
Well, my printer didn't work. My copier didn't work. I'm gonna have to go back and redo that.
We only need even numbers.
Well, the printer didn't do what it was supposed to do. It was supposed to do front and backs.
Get all of your back, on front and back. Like, you know, your odd pages, front back, 31, 33.
Really?
32, 30. Does yours have all of them? Yes. The one that you personally look at? Oh, yours is.
Well, this is the one I took apart. I know what I did. I realized what I did. I did what I do all the time. So normally what we do is we take a single sided and we tell it to run and make it double sided. I should have said double sided to what? Double sided. But I'm, so we're looking for this picture right here. This is our input module. Okay. And then when we pull it out, so y'all can go ahead and unscrew it and pull it out. You probably already had to pull it out to get to your power supply anyway. Mine goes so screwed. We got the gray ribbon cables back there also. And I don't remember how many they had back there. They've only got the two. So we're looking at SV1 and SV2, right? Everybody okay? Yes or no? Huh? So these are the only two. We're not looking at the big ones. These are the two cables that we use, the two ribbon cables that we use to wire up these input switches. Everybody okay? Yes. Well, everybody okay there? So what we need to do is figure out what chart we want to use. So you're going to double up. There's plenty of room to double this up in there. And that way we can play around with it. So what's the one, when I turn the page, I think this is table 4-4.4 and 4.4. Yeah. Well, we've already hooked up the connectors on the front, connector A and connector B. Now we're going to hook up more inputs. So we're going to double up. We're going to put 2 pins inside one slot. Okay. SD1, SD2. We're not using 3 and 4. So pin 1 is still, huh? Yeah, so here's the drawing, and what they do is on the even page, that's not what this deals with. It deals with pages after that. So let me get my let me get my copy. Oh, here's my copy. So what you're looking for is you're looking for table 4.4. Right? Anthony, you okay? I'm still looking for it. Here's the switches right here. It's on the back of the page. This is in section 4. So everything about this is in section 4. So SD1, SD2. We need to figure out which one that's SD1. Right. Then the actual pin out is table 4, not 4. Yeah, we're not using 3 4. For power, right? Power.
Yeah, but I thought we were using the first and fourth.
Sure is.
Yeah.
Yeah, it's on your model. But I could have an infant dog, somebody else can have an infant dog.
Oh, yes.
We'll remove no. Right. So we're saying this is SD1.
So, this one right here, is 2.
And once I go to the model, it's 2.
And that's, what they left it there? That's saying that this one here is 2. That's,
So let me run off some. Are we okay so far? Sure.
right here. Switch SV2.